The last thing we are going to learn with these notes are the exact values of trig ratios. This is present in this book that I have for you, the book that you guys all have. I don't see it present in any of your texts or on any other IB texts for this class. I do not see the requirement for you guys to know the exact values of the trig ratios. So I don't really know if it's going to be expected of you or not, but I just thought we would talk about it really quickly. When we're talking about exact values of trig ratios, we're only really ever talking about 5 angle measures. Those angle measures are 0, which your calculator gives it to you exactly anyway, 30, 45, 60, and then 90. 0 and 90 your calculator give to you no matter what, because they are already exact. They're either 0 or 1. 30, 45, and 60 are not always given to you in exact values on your calculator. And so if you're asked for the exact value, we're looking for like the square root of this over this. But here's how it goes. First, I'm going to talk about 30, 69. Actually, no, I'm going to first talk about 45, 90 right triangles. If I want to talk about the 45-degree angle, I'm going to draw a right triangle where the angles are 45. So if we're talking about a 45-degree angle in trig at all, we're talking about a right triangle that's an isosceles right triangle, right? If we've got 2 base angles that are equal, that means that there are 2 side lengths that are equal. If I wanted to label this side length as 1 and this side length as 1, because they're both equal to each other, I can solve for the hypotenuse. How I would solve for the hypotenuse is my Pythagorean theorem. C squared, my hypotenuse, is 1 squared plus 1 squared. So C squared equals 1 plus 1, which is 2, which means that C is equal to the square root of 2. So I'll go back up here and relabel it as the square root of 2. And you could have, no matter what, any other triangle that's a 45, 45, 90 right triangle, an isosceles right triangle, is similar to this triangle, which means that their relationships of their side lengths are proportional. So the ratios of their side lengths are proportional. We'll talk a little bit about what that means. But no matter what, sine of 45 is going to be 1 over square root of 2. Always. Which is how this all works anyway with sine and cosine. If we're talking about side lengths of right triangles and the relationships of their side lengths, if you have a 30, 60, 90 right triangle, all 30, 60, 90 right triangles are similar to each other, meaning that the ratio of their side lengths are proportional, okay? Which means that they would all simplify down to the same fraction or the same number. So sine of 45 is going to be 1 over square root of 2. We typically don't like to leave it like that, so we would multiply the top and bottom by the square root of 2, and you would get square root of 2 over 2. For those of you who might have started off in a different class and then moved into this class, you might have talked about radians, maybe, and talked about the unit circle. If you don't remember the unit circle at all, that's fine, don't worry about it. But the square root of 2 over 2 is one that you see in there. So you could go into your calculator and calculate the sine of 45, and then you could go into your calculator and don't do the sine of, just type in the square root of 2 divided by 2, and notice that they are the same number in your calculator, 0.707107, da 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 da. Cosine would be the same. So go back to the very beginning of our notes and notice that we were looking at these values, but just as decimals. And tangent of 45 is 1 because the two side lengths that we're comparing to each other are equal to each other. So the relationship of them being divided out is 1. So those are your exact values for sine, cosine, and tangent of 45. And that's how it's made, is that you've got this idea of an isosceles triangle. You multiply all, or you label the two side lengths as 1, and then solve using your Pythagorean theorem for that hypotenuse. 30, 60, 90 is going to be the next one we're going to explore. Right triangle. 60 is the larger, 30 is the smaller. So what we do to solve for a 30, 60, 90 right triangle, how these exact values were found, is that we actually duplicate this 30, 60, 90 right triangle to the other side, making this guy 60, and then this whole angle then becomes 60 with the addition of the 30-degree angle right there. So all of those angles are equal to each other, which means it's an equilateral triangle. So if I were to label this side length as 2 and this side length as 2, realize that this whole side length would be 2, but that means that this side length right here is 1. That's pretty much how we got those numbers, was this idea of that a 30, 60, 90 is exactly half of an equilateral triangle. Now, taking that, we can solve for the one missing side length that we have, again, using your Pythagorean theorem. 2 is your hypotenuse, so it would be 2 squared equals 1 squared plus b squared. So that's 4 equals 1 plus b squared. So that's 3 equals b squared, which means that the square root of 3 equals b. Going back up here and placing that number where it belongs. Now I've got all of my side lengths represented, and now I can find sine, cosine, and tangent of 30, and 60. Sine of 30 is going to be opposite, which is 1 over hypotenuse, which is 2, a half. And you'll notice that when you plug in sine of 30 or cosine of 60, that you'll get 0.5, a half. Cosine of 30 is going to be adjacent over hypotenuse. And tangent of 30 is going to be opposite over adjacent, which multiplying the top and bottom by the square root of 3, I get that. Sine of 60 is going to be opposite, which is the square root of 3 over hypotenuse. Cosine of 60 is going to be adjacent, which is 1 over hypotenuse, which is 2. And then tangent of 60 is going to be opposite, which is the square root of 3 over adjacent, which is 1. So it just simplifies down to the square root of 3. So those are all of your exact values of your trig ratios. Those are the ones that we tend to focus on. You can find exact values of pretty much most of them. I mean, they're infinite, right? But like you can find exact values for a lot of them, but these are the ones that we tend to focus on. So you'll notice 45 and 30 and 60 a lot. The key word here is exact. If you're asked for exact, you cannot give a decimal. You have to know these ratios. These, again, I couldn't find any like IB problems that involved this, but this is in your book and your book asks you to know it. And so I just wanted to like throw it out there for you guys to know. Now, this is a 30, 60, 90 right triangle, and I want to solve for x and y. How I would typically solve for these guys is I would draw a 30, 60, 90 right triangle and label my side lengths with what I know is them. I can even reimagine it and rebuild it with this idea of the equilateral triangle and piecing it all together. Now I notice that x corresponds to 1, y corresponds to 3, right? X corresponds to 1, y corresponds to 3, and 6 root 7 corresponds to 2. Those are your corresponding parts, the parts that match up. They may not be equal, these side lengths, right? 2 and 6 square root of 7 are not equal, but we know that the relationships of the side lengths are going to be proportional because these guys are similar, because all of their angles are equal. So if I wanted to solve for x, I could set up a relationship between x and its corresponding side. So I would do x over its corresponding side length, which is 1, equals. And then I have to use the number that's given to me in my original triangle. X is on top with that first fraction, which means that my second fraction needs to have that same triangle on top. So that would be 6 square root of 7 over, and then its corresponding side length on the other triangle is 2. So now I only have one variable because I definitely referenced back to the number that I do have in the triangle. And now I've got proportional or ratios between side lengths, which are proportional. Cross multiplying and solving, I get 2x equals 6 square root of 7. Divide both sides by 2. Realize that 2 only divides out with the coefficient, not inside of the square root, because it would have to also be inside of the square root. So x equals 3 square root of 7, and that's exact. Y corresponds to square root of 3. Again, I'm referencing back to 6 square root of 7 to the hypotenuse on the other guy, which is 2. Cross multiplying, I get 2y equals 6. The two square roots then now multiply together to become the square root of 21. Dividing both sides by 2, I get y equals 3 times the square root of 21. That is how you solve for exact side lengths. Once you know what those angles are, then build your basic, like these guys, your basic 30, 60, 90, or your basic 45, 45, 90, and then build from there. Set up your proportional relationships and solve. Again, I'm going to do that here, building my 45, 45, 90, 1, 1, square root of 2. Just this general idea for me of like what matches up with what. Since I see that this guy is 45 degrees, I see that this guy is 90, I know that this guy must also be 45 degrees, which means I can actually automatically solve for a couple things right here. If this side length right here is 8, that means that this side length will also be 8. So I know that y equals 8 right away. Now, setting up my side lengths, 8 matches up with 1. And then x matches up, it's the hypotenuse, and it matches up with the square root of 2. Cross multiplying and solving, x equals 8 square root of 2. Now, shifting gears, we're looking at this right triangle in order to solve for z and w. It's another 45, 45, 90, which means that we know that z and w are going to be equal to each other, but we need to solve for them first. Z matches up with 1. Equals, and then what we do have in that triangle is the hypotenuse, y, which is 8. And that matches up to the square root of 2. Multiplying top and bottom by the square root of 2, I get 8 square root of 2 over 2, which is 4 square root of 2. So I get that z equals 4 square root of 2, and w equals 4 square root of 2. And that is it for your notes. There is one homework assignment. Actually, no, I don't think I put that one homework assignment in, so I don't think there's any homework problems that involve something like this. But it's good to know and have just on your periphery. For those of you that want to get 7s, this is something that you should know and just have ready to go. Okay, good job today, guys.